Might be. Okay. So we talked about saturated and unsaturated fats, and this is where hydrogenation comes in. Can you see the word hydrogen and hydrogenation? So basically, when we hydrogenate non-saturated fats, when we are making it no longer a double bond. So if we partially hydrogenate things, let's see, to alternate, an alternate to hydrogenation that won't give you the trans fats is you scramble fatty acids on, how many, in triglycerides, how many fatty acids are there? 3. That was what I was after, 3. On 2 of the 3 fatty acids, you scramble them. Let's see what our things look like. Here's our pictures. Where's our pictures? Oh, goodness gracious. All right, so this is kind of showing you the scrambling. That's without hydrogenation, how to try to kind of get some of these double bonds gone. Now remember that, well, I'll ask this in the form of a question. What do you guys think? This guy up here, definitely unsaturated. You see double bonds, you know it's unsaturated. Is that cis or trans? How many people think that that's cis? I do. Cis, they're on the same side. Okay, yep, those are cis.
What's on the same side, the bond?
Well, I kind of think of it as, this is the carbon group, but what they did is they thought of it as we have hydrogen. The hydrogen's on the same side of the bond too.
Is that like when that girl that did this?
Yeah, that's when that girl did this. When she goes like this, it's cis. When she goes like that, it's trans, because it's kind of opposite. So this is kind of fun. You see your 3-membered, your triglycerides, and these are your fatty acid strands. So you take 2 of these and you submit them to a chemical or enzyme, and you kind of get a hybrid out of it. So you can see what happened is when I compare the 2 reactants with the product, what's different? What's different about this product down here? Yep, to me it's that guy right there. So basically that got swapped out by one of those.
Yeah, like the middle one.
Mm-hmm. And this middle one, to me, kind of came from this one.
So the bottom one is better?
It's more, let's see, saturated. This is more saturated.
You want it more saturated?
Without hydrogenation. Do we want it more saturated? There's advantages. I think you're supposed to have a combination of saturated and unsaturated. Okay, but this is still unsaturated, but it's not as much unsaturated. I don't know. I don't have a firm answer to that. Switching gears now from the oils and all that to carbohydrates. Oh, I love my carbs. When you think of carbs, what do you think of?
Bread.
Bread? I do too. What's that? People dieting, avoiding carbs, bread, sugars. Exactly, carbohydrates. So carbohydrates contain carbon and hydrogen, oxygen, go figure. Sugars are carbohydrates, and so are starch. So yeah, the breads would be our starches, and of course sugar. They're both carbohydrates. Carbohydrates, if you look down to the nitty-gritty, have in general a ratio of, for every oxygen, there are 2 hydrogens. For every oxygen, there are 2 hydrogens in carbohydrates. Well, mono means 1. So saccharide, to me, I think of sugar. Monosaccharides, okay, like glucose and fructose.
This kind of goes back to like the carbohydrates. Is that why water, like a water diet is good because of the 2-to-1 ratio?
No, I think it's a metabolism thing. Why water just kind of takes, water is good to kind of, I've heard, get out toxins and things like that.
Well, yeah, I didn't know that like had a factor in it since it's,
yeah.
You know,
I don't think so. But there is an interesting similarity, isn't there, between carbohydrates and water.
Yeah.
I'd like a sugar diet, quite frankly.
Yeah.
Okay, the word there is single ring. So we're going to see some ringed structures here. Glucose and fructose. Glucose and fructose. That's better than those L amino acids. Let's see how they differ. They just differ by where the hydroxyl, the word is hydroxyl there. They just differ by where the hydroxyl group is. Hydroxyl is an OH. So let's see if we can tell the difference. These are two forms of glucose, and this is fructose. So tell me what carbon where's the difference between these two?
It's missing a carbon on top.
What's that?
There's not a carbon on top.
CH2O.
What carbon number are you talking about? Number 5?
No, wait. Wait, move it over. Wait.
One's an X carbon.
Ah, that's true. This is a 1, 2, 3, 4, 5, 6 membered ring, and this is a 1, 2, 3, 4, 5 membered ring. Cool.
I thought you were supposed to stay away from all fructose and glucose and stuff.
Well, that's a whole nother discussion. We're just looking at the molecule for now, but I had heard something too. It frankly confuses me. So we're supposed to stay away from fructose. I don't think so. Sucrose. I don't know. But we have glucose and fructose. In a minute, I'm going to talk about sucrose, and actually, sucrose is a combination of these two. So let's go back to the whole 5 or 6 member ring and 5 member ring. Check this out, though. This one, it's kind of like one of the. See how it has just one carbon group off of there, and this one has 2. So actually, they have the same number of carbons. It's just that you're right, 6-membered ring and 5-membered ring. Interesting. Okay. So I have carbohydrates. I got a video. What was the previous slide? Carbohydrates. Okay. So we have these monosaccharides, the basic units. And didn't he just say that there's 3 monosaccharides? He said glucose, fructose, and what's that?
Sucrose.
No, sucrose is a disaccharide. No, it starts with the letter G, I thought. So let's look at disaccharides. So you take 2 of those together, 2 monosaccharide units, and the only monosaccharide units from the previous slide were fructose and glucose. So glucose is mono, sucrose is di. Okay? And I think I have a video to kind of maybe show you how this works. So we're going to join 2 monosaccharides together. Sucrose, you get an alpha glucose and a beta fructose. Alpha glucose, beta fructose. So sucrose has got glucose and fructose in it. And they're connected by COC linkage? Carbon, oxygen, carbon. That's what COC is, carbon, oxygen, carbon linkage. And what happens is what we call a dehydration, so water is removed, or condensation, dehydration. So here we have them lined up side by side on the previous slide, alpha glucose, beta fructose, and you can see the red hot, the OH here, the hydroxyl group from your glucose, one of the hydrogens on the hydroxyl group, your fructose, that's going to go out together, and then oxygen is going to join with that carbon. Looks like this. Okay, so if you look from the reactants to the products, we still have kind of our glucose structure and a fructose structure, but now we've taken out a water molecule, which was this H2O that went out. So that's sucrose. And I like the video we watched because actually fiber can have these monomers, these monosaccharides, but the linkage is different. The linkage can't be broken in fiber like it can be broken here. So this is the linkage we're talking about right there. That's your COC linkage. So sucrose is a disaccharide. Polysaccharides, when you have 3 or more, and actually I think in the video we watched they call it oligosaccharides, between 3 and 10, and beyond 10 is polysaccharides. You might have run into the word polymer before, and actually plastics are a polymer. All a polymer means is they've taken a single unit and strung it together, connected it. That's a polymer. So polysaccharides do that, take these little monosaccharides and make a big thing out of them. So, because single sugars can be either alpha or beta, there's 2 different linkages that can arise. Oh, so this is what we heard in the video, the alpha linkage versus the beta linkage. The alpha one's easy to break, the beta one not so much, right? So just take plain old glucose and polymerize it with alpha linkages and you make starch. Alpha linkages. Take that one glucose that we saw before, do glucose to glucose, glucose to glucose, glucose to glucose, etc., and you'll make a starch molecule. Beta linkages, and you'll make cellulose. Now, which one of those do you think we digest? Starch or cellulose? Starch, yeah.
What about alpha to beta? Because that's what this is here.
Now the alpha, let's see, the alpha to beta, I'll just show you here. When it's talking about a linkage, it's not talking about this. It's talking about this.
Oh.
So, I mean, that's what I'm thinking. So here we have what would, this is an alpha linkage. So this must be starch. You can put starch for A. And here we have a beta linkage. So that would be cellulose. But they have the same repeating unit, which is a glucose unit. That is so cool. So they're all glucose units, but this is starch. And this is cellulose. Wonder if that's, to me, when I think of cellulose, I think of cellulose like building up in my legs, cellulose. I don't know. I think it's different.
Cellulite.
Cellulite, thank you. Okay. So you can almost see, to me, which one looks cis, which one looks trans to you guys?
Cellulose looks trans.
I'm thinking, yeah, this looks trans to me. Does that make sense? And this, to me, looks kind of like a cis sort of thing.
So cis is good.
Cis breaks down. Yeah. But you know what? The thing is, do we want it to break down? Because the problem when we eat starchy foods is we metabolize it, and then those things go ahead and find their way to be stored or whatever. Hopefully used, but if not used, stored. I think that's the way the body does it. Whereas this might fill us up, cellulose, and our body can't digest it, so it doesn't become a part of us.
So why is that? Why is trans fat so bad?
Well, that's a different thing. Yeah, yeah, I know. It's like I know trans can be good here in this sense, but trans fat is bad. I know. You're like, oh, the chemistry of it. Okay, so starch. Starch we find in bread and potatoes. Cellulose we find in plants. Ooh, cell walls of plants. One of my husband's favorite thing, and so I'll buy celery. I'll buy a lot of things and not eat them. But celery's not too expensive. But anyway, celery, negative calorie food. That's what they say. What's that?
Negative. Because you use more calories chewing it.
Yep.
As long as you don't put a bunch of dressing on it.
Yeah, don't put dressing or peanut butter or yeah.
It's horrible. Like,
Yeah.
So. Okay, so glycogen. Oh, that was the third one, glycogen. No? That wasn't, I guess. Because glycogen has a similar structure to starch. Starch is a polymer, polysaccharide. Okay. All right. Glycogen has a similar structure to starch. We humans are able to digest starch, but we lack the enzymes to digest cellulose. You ever wonder, like, what life would be like on other planets, and like how would it be different? How would it be like? I do. And also keep our same planet. I'm thinking this is right, and I bet Ms. Roscoe-Lamar could say, but some animals can do have the enzymes to digest the fiber.
That's why they can eat grass and be fat like a cow.
Okay, there you go. I think you're right. Okay, I'm gonna play this video for us, but some sweeteners taste sweeter than other sweeteners. Did you notice that? So here are some sweet things: lactose, maltose, glucose, honey, sucrose, and fructose. And there's a sweetness scale. Like, how'd they come up with that sweetness scale? These guys down here are artificial sweeteners. And as far as encouraging you to consume them, I would encourage you to consume these, but not as necessarily a full dose of these. My kids got on me one time years ago, Mom, you drink too much Diet Coke. Okay, and they're right. Okay.
7 to 13,000.
What's that?
7 to 13,000.
Right. I'm not familiar with neotame. I've heard of aspartame, saccharin, maybe
Can I
sucrose.
see what neotame is? Can I Google it?
Sure.
That's one of the substances
What's that? Oh yeah. So if it's got this high sweetness thing, man, all you gotta do is put an old drop in there.
But in the book, it doesn't really say that any of those are bad for you. They say there's not really any true evidence.
We'll watch this video.
Diet Coke's really bad. Even though it doesn't have like calories.
Well, maybe Coke is bad for you. You know.
Not just right.
Diet's actually worse. Anything diet's worse than regular.
Yeah, and the thing about diet things, maybe you guys too, it's like you drink it or consume it and you want more and more of it. I mean, it's almost got like this drug thing going on. I mean, it's probably just a craving thing.
My brother eats diet every day and he's about 450 pounds.
He weighs what?
About 450 pounds.
I don't think
Yeah,
Diet
see,
soda.
it's not fair. It is not
Diet
fair.
everything.
And I also
He's
think,
5'6".
Yeah, he's quite round.
I also think that, anyway, I think people who are economically challenged sometimes can, I don't know if it's falling into traps or it's just the food that they or we eat, but can gain weight too, you know what I mean? So anyway, so the two words are natural and synthetic. That's frustrating, by the way. And the first paragraph here says that what they do is they compare everything to sucrose, which is 100. And like, how could you, everybody's taste buds are different too. I don't know how they do that. So there's concern about health impacts of the amount of sweeteners that people consume per day. It doesn't say natural or artificial, it just says consuming too much sweeteners. So let's watch this video. Did you find anything about the neotame?